Hello everyone. As we go through chapter 5 and work in 2 dimensions, one of the things we need to do oftentimes is take a velocity that's acting at some angle relative to the horizontal and break it into its perpendicular x and y components. The reason we have to do that, of course, is because gravity only acts on the perpendicular, or the up and down, the vertical component, and it does not affect the horizontal component. So we need to know how much of a given velocity is up and down and how much of that given velocity is side to side. Let's look at how we do that. I just made up some numbers, but let's assume for the moment that you launch a baseball or a football or something at 14 meters per second at an angle of 29 degrees above the horizontal. We can think of that 14 meters per second as having a horizontal part and a vertical part. And those parts are actually just the sides of a right triangle that are formed when we draw the horizontal vector and the vertical velocity vector. We're going to label these two components, these parts. Vy for the vertical velocity. You know, that's really could be thought of as the initial vertical velocity, really, because this part is changing as the ball goes up and down, because gravity affects this one only. So how do we find these components? Well, let's start with the vertical component. Vy, the vertical component, is opposite the angle theta, in this case 29 degrees. And we know the hypotenuse is 14. So the function that links opposite and hypotenuse, of course, is sine, SOHCAHTOA. And we're going to use sine then to calculate this component of the 14. I'll start off by just saying that sine of 29 degrees in this triangle is equal to opposite Vy, or again, you could call it V naught y, over the hypotenuse, which is 14. Because we want the y component, we're going to multiply both sides by 14. And recognizing that the 14 meters per second cancels on the right, we're left with the y component equals the hypotenuse, in this case 14, times the sine of 29 degrees. I'm going to grab a calculator and we'll do that. On these old school calculators, I prefer to do this first and then multiply by 14. So I'm going to put in the angle, 29, hit sine. The sine of 29 is a little less than a half, 0.48. And 0.48 times 14 is probably going to be a little bit less than 7. It is 6.787. I chose to round this to 3 places, just because, or 2 decimal places, just because I'm going to use this later and I don't want it rounded off to 6.8. Let's go ahead and look at the x component. The x component is the adjacent side of the right triangle formed by these 3 pieces, the 14, the y component of the 14, and what we're going to calculate now, the x component of the 14. Because it's adjacent and hypotenuse that we're working with, cosine, ka, adjacent and hypotenuse, is the trig function we're going to play with. Cosine of 29 degrees is going to equal the x component, Vx, adjacent, divided by hypotenuse. Just like we did before, multiplying both sides by 14 gives us Vx, the x component of the velocity, is equal to 14 meters per second times the cosine of 29. I'm going to perform this on the calculator again, doing this first. 29 cosine is a little bit more than 0.87, and that times 14 is 12.24. I'm going to put these values into my drawing and talk about one quick thing. Okay, in summary, we used sine and cosine to find the vertical component and the horizontal component of these velocities. We have to use these in the problem. We cannot use the 14 because the 14 isn't all vertical or all horizontal. It's a mixture. And we need to know precisely what part of the 14 is purely up and down. In this case, it's 6.79 meters per second is the up and down speed initially. Gravity affects that during the whole flight. And we need to know how much of the 14 meters per second is horizontal. And that's 12.2 meters per second of the 14 is purely horizontal. This will stay the same the whole flight and is unaffected by gravity. The only thing I could have said at the very beginning is we could have called this v, like the actual velocity, or you even could call it v naught. But the point is, we can't work with a velocity at an angle. We must break it down into its perpendicular components, the component that's up and down and the component that's side to side. I hope this is useful, and we're going to do a sample problem in class related to this right after we watch this video. Thank you.